Hello everyone, my name is Sohan Kumbar and today I am excited to share my journey and project work during my 30 days embedded system internship at Emertxe. Over the course of the internship, I learned embedded C programming, explored microcontroller level development and finally implemented a simulation of washing machine system using PIC16F877A microcontroller in PICSimLab. Uh, this is a table of content in which we go through overview, our internship goals, learning journey, introduction to embedded systems, tools and platforms that are used, project requirements, system design of a project, development process, implementation details, in which we will see the demonstration of the project, next challenges and solutions, key learning and conclusion. Let's move to the internship overview, in which the duration of this internship is 4 weeks, focused on core C programming, which is foundation for embedded system development, then embedded system concepts, microcontrollers, timers, interrupts, input output and other peripherals of embedded system. In lastly, project implementation, washing machine simulation using PIC16F877A on PICSimLab. Let's move to the learning journey, which is timeline. In week 1, we learned about core C programming, learned fundamentals, programming concepts, focused on data types, loops, array, functions, and structures, gain confidence in writing modular and efficient C code. Then in week 2 to 3, we learned about embedded system development, in which we worked on microcontroller input output, which is PIC16F877A, wrote programs for LED blinking and switches, and in switches we learned about level and edge detection. Next we explored about timers, interrupts and digital keypads, and interfaced with peripherals like character LCD, buzzer and fan for motor simulation. In the final week project, in the final week, the project implementation is done, in which we combined all the concepts that we have learned before in single application, designed and simulated a washing machine with real-time mode switching, then handled input selection, display updates and hardware simulation using PICSimLab. Let's move to the next topic. What is embedded systems? Here is the definition. An embedded system is a dedicated computer system designed to perform one or a few specific tasks. It is embedded as a part of a larger device and usually includes both hardware and software components. These systems are optimized for performance, reliability, and efficiency in real-time operations. Here are some real-life applications of embedded system. In home appliances, embedded systems are used in washing machines, microwaves, and air conditioners. And washing machine is our project, which we will see in next slides. Next, in automotive systems, anti-lock braking systems, engine control units, parking sensors, which are the examples of embedded system. In medical, heart rate monitors, infusion pumps, and in consumer electronics, smart TVs, wearables, mobile phones are the real life applications of embedded system. And most importantly, in industrial automation, which is based on embedded system only, in which we will see PLCs, robotics and data loggers, which are based on embedded systems. Let's move to the next another topic. What is microcontroller and microprocessor? Here is comparison of microcontroller and microprocessor. So let's see. Function of microcontroller is a dedicated control task which means microcontroller is used for dedicated work, and in microprocessor we use microprocessor for general purpose processing like our computer systems. Components of microcontroller consist of CPU, RAM, ROM, input output on one chip. Everything consists in only one chip. But in microprocessor it is only CPU. External peripherals we have to connect externally, like input output devices and some other things, memory devices we have to connect externally. Let's in power consumption, microcontrollers power consumption is very low and microprocessor comparatively takes higher power. Next is cost. Cost of microcontroller is low, but in case of microprocessor costs are very high. Some are examples of microcontroller like PIC16F877A at mega 328, and in microprocessor we have seen the Intel i5 and AMD Ryzen's, which are used in laptops and computers. Next, move to the embedded system architecture. The first part of the architecture is processor or core, microcontroller or DSP for task execution, which is CPU. Then next is memory unit. In memory unit, ROM for firmware and RAM for runtime data. ROM means read-only memory, in which the data is stored permanently like our firmware or software, and RAM is random access memory, which is used for processing. Next is input devices like switches, sensors are the some of the examples of input devices. Next are output devices like display, actuators, buzzers and motors. Next is communication interface. To communicate with each other, like processor to input device or output device, we use communication interface like UART, I2C and SPI are some of the protocols of communication. Next is software. Firmware written in embedded C or assembly. Our uh, washing machine's code is written in embedded C. Next, move to the tools and technologies that are used in washing machine project. Microcontrollers that is used is PIC16F877A, which is 40-pin and 8-bit microcontroller from Microchip company. Here are some of the features of controller, like it consists of timers, analog to digital converter, UART and multiple IO ports. This PIC controller consists of 5 ports, which we will see in next slide. This processor is ideal for learning embedded fundamentals and simulation based projects. The IDE integrated development environment which is used is MPLAB X, and the compiler used is XE8 compiler. This IDE is also developed by Microchip Technology, provided compiler, debugger and code editor. We used this to write and compile and manage the embedded code of our project. And simulator that is used is PICSimLab, which is open source simulation tool for PIC microcontrollers. Allowed hardware like testing of code without physical components. It helped to visualize input and output like CLCD, switches, buzzers and fan. Our project is also we have to run on this PICSimLab. Then peripheral components. First is CLCD, character LCD, which is used to display system status like washing, rinsing and spinning operation. Next is buzzer. Buzzer is audio indication of cycle completion or for alert or warning system. Then there is fan. Fan is used to simulated washing machine motor, which is used as motor for our washing machine. Next is keypad. Keypad is used for user input for selection modes of the washing machine. Then brief project requirements are here. Objective is to simulate a fully functional washing machine using PIC16F877A microcontroller, showcasing real-time embedded system control with user interaction and output feedback. The cycle modes are idle, wash, rinse and spin. In idle mode, default state when no input is selected. In wash, the simulates washing process, then rinse cycle, and then spinning for drying the cloths. Input mechanism consists of digital buttons, that is digital keypad used to select desired washing mode, and there are output components like CLCD, fan, buzzer. CLCD is the display to used to display the current status of the washing machine. Then fan is for motor simulation, operates during active cycles to represent the washing machine motor. Buzzer is used to activate indication cycle completion or alert systems. Then next is system design. System designs consist of the microcontroller PIC16F877A. Here is the block diagram in which there are some input devices are connected and some output devices are connected to microcontroller. The washing machine control system is designed around the PIC16F877A microcontroller. It connects to multiple input and output peripherals, in which keypad for mode selection, CLCD for displaying the current system status, and fan is used to simulate motor operation, and buzzer provide audio feedback at cycle completion. Here are GPIO configuration in embedded C. This is the pin diagram of PIC16F877A. There are 5 ports like RB and RB, RC, RD, and RA port is also available. Each IO pin on the microcontroller is associated with port, which is port X. Here X represents the A, B, C, D or E port. Port is used as for data register, and tris is used for direction control register. So in tris register, which controls the direction of the port pins, if we set as 1, then it is represented as input, and if we set as 0, then it is represented as output of the pin. Then GPIO pins used. For keypad we used port B, RB0 to RB3 and RB4 to RB7 columns. Then LCD is connected to port D, fan is connected to port C, and buzzer is connected also to port C, which is RC5 pin. Then next is development process of the project. First is requirement gathering. Understood the working of basic washing machine, how washing machine works. Then finalize the 4 main modes: idle, wash, rinse and spin. Then choosing the microcontroller is the main part of the project, which is PIC16F877A as the main controller. Then map the required components: keypad for input, CLCD for displaying status, which is output, fan to simulate the motor, which is also output, and buzzer for cycle completion and alert system, which is also output device. Assign GPIO pins based on the peripheral needs. Then next is code planning and pseudocode. We have broken down the project into smaller functional blocks, wrote pseudocode for each mode, then created a flowchart to visualize logic and transitions, defined variables for timers, display messages and system status. This helped me to write clean and modular code from the start. Then peripheral testing. Use PICSimLab to test each component separately, verified GPIO output using LED blink tests, configured and tested timers for accurate delay cycles, initialized and displayed message on the CLCD, then triggered the buzzer and fan individually to confirm the output functionality. Then next is final simulation. after simulating the uh, block of the codes, then there is a final simulation where we ran the complete project on the PICSimLab, in which it consists mode selection via keypad, worked as expected, then verified correct status display, motor motor activation, and buzzer alerts. Observed real-time behavior like an actual washing machine. This confirmed successful project implementation and logic flow. Here are some implementation detail in which we will see the full demonstration and code of the project. So this is the main.c file, which is the main file of the project, and here are all the files like header files and all the C files also available. So for the LCD code is written on separate files. Then here is interrupt service routine and digital keypad. Then this is main file, and for the timers the code is written separated. And here are some function definitions, and also here are all the header files that is required to run the washing machine project. So if we compile the uh, main.c, we can see here build is successful and how our hex file is stored in some location. Then we will move to the uh, PICSimLab. So in the PICSimLab, if I load the hex file from the location, this is the my hex file. If I load the hex file, then display output is shown on the display. Like press key 5 to power on washing machine. Here RB0 is our key 1, RB1 is key 2, key 3, key 4 and key 5, and likewise. If we press key 5, then machine gets started. Powering on washing machine is displayed to the user. And here are some washing programs like daily, heavy, dedicates. Then we can select from here from the RB3 button, and some are the whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, and again the loop is continued to the daily. So I select whites. For selection we have to long press the RB3 button. So now there is water level, which is there are auto, low, medium, high, max, and again the auto. So I'm gonna select the medium. For selection we have to long press the RB3, then press switches. If we press switch 5, then it will start the process. If we press the switch 6, then it will abort the process. So our switch 5 is RB4. So let's start the process. So our time is started. First function is wash, and time is also started. So we can start or pause the process in between. So if we press switch 6, then it will pause the process, like I paused it. And then if we press switch 5, then it will again start from the that time. So now it started, and we assigned the RB0 for the doer, If we long press the button, then door will get opened and alert is given to the user. So now door is open and alert is given. If we release the RB0, then door is closed and again the program is started from that particular time where it is stopped. So now rinse operation is started. According to the mode, the time for the various function is assigned properly for the rinse operation, spin operation and wash operation. So now rinse operation is completed and spin operation is started from 10 seconds. So now our program is completed. Message is given as remove your clothes. Now again the program started from first. So this is the complete demonstration of the washing machine program. So I hope this video is helpful for you. Thank you.